We're good. Hello, hi everyone. It's 12 on the dot. My name is Robert Wolf, 96Boards Community Manager. Monty over here, Application Engineer for 96Boards. And today we have a dual kind of session, all in one, about the mezzanine ecosystem. So he'll take over about halfway. Okay. So first things first, the 96Boards mezzanine ecosystem. I want to kind of give a throwback to yesterday. Dieter and Bill from Aero Electronics gave a really nice session on all of the different 96Boards hardware that they've been working with. So whoever's watching this should go back and try to find their session and watch that as well. But today, we are going to talk about a little bit more kind of on the open source, how to get involved. And these questions came up in Dieter's session is, how can the community start to participate in the outputs that the big companies are doing around mezzanines and around 96Boards to kind of grow this ecosystem bigger. So this is our outline. I'll try to get through most of this quick. Monty is going to address more of the technical aspects after I talk about the initiative in itself. So, mezzanine, status update, current updates. Well, long story short, it's just going so fast I can't even keep up. You come to these events, you check online, and then next thing you know, there's mezzanines that I had no clue about. So, long story short is that it's just going so fast, and I do my best to keep this website updated. But for anyone who's interested in knowing what we're aware of about mezzanines that are going out here, this ecosystem that continues to grow at such a rapid rate, you can go check out the 96Boards products website there on the mezzanines page and find out as much as we know, and hopefully that continues to grow. As you can see, these are slides that were reused from our Budapest session from Amit Kucheria. Excuse me. But here are some of these kind of, I want to say, application spaces that can be, that mezzanines have started to surface in. So you have mezzanines that are all I/O, ramping up, bringing down voltages, different interfaces that you can use. A lot of times these ones tend to gear towards makers, but using sensors that are available for purchase and make you have a strong path to product, right? I'm just going to kind of get through these really quickly, but you can just see how they're just popping up everywhere. Funny story about this one. We have this AI Starvision mezzanine, some folks in this Bay Area, they needed cameras, and so they just made a mezzanine, and now they're selling it on eBay. Right? So people are just, like I said, they're popping up everywhere. Some display mezzanines, connectivity mezzanines, these are being showcased down on the Aero booth if you ever want to go check those out. Security mezzanines by Hope Run, debuting at the Hope Run booth. Downstairs you have a Secure 96 mezzanine, and this was also talked about Joaquin, another session that should probably be checked out for anyone who's watching this. Check out the Secure 96 mezzanine session. And what is the point of all these mezzanines? So the point is to offer anyone who is developing a strong path to a product. And so these products are usually in some of these verticals. I know there's more verticals out there, but catering to these verticals, the mezzanines offer you that path. And working with the people who are releasing these mezzanines offer you even a stronger path. So you can see kind of just some tables here. Again, I don't want to talk too much about it, but more of this, what I want to talk about is the initiative. I'm just giving a little bit of an update as to what's going on around here. Different verticals tackled by different mezzanines and how you can kind of apply them to your development. Okay, this is the purpose. This is why I'm here. And so before I move on, I want to kind of just mention why the Mezzanine Community Initiative meant so much to me. I'll introduce Michael Welling. I'll let him give a little talk in a second. But I was kind of troubleshooting some stuff with Gordon, other folks, Gordon from Gumstick, some other folks in the community. And then we thought, hey, you know what? All these people that are talking to me, they have such great ideas, so many things that they want to develop, so many products that deserve, a chance. And how do you give these products a chance if, the ecosystem isn't moving towards those people's needs? So, brainstorming with Michael Welling, we come up with this idea to create a repository that offers this path for people to express what they want out of the big game changers, people who actually have the capability to create things, and the people who have the ability to sell them. Because I may only need one mezzanine and I don't have the money or the time to drive this forward, but maybe other people see a need in it as well, and so it can all be contributed together, right? You know, that's the whole point. This is a repository. It's brand new, probably a couple months old at this point. Still needs a lot of work, but for anyone who's interested in checking this out, you'll have a lot better idea as to what I'm talking about. The place to congregate around building a bigger and better ecosystem around 96Boards. So, if you build it, they will come. This is a myth. It's not true. Because, from Field of Dreams, anyone who's seen that movie, right? But if you build it, they will come is not necessarily true, especially when you're working on the things that we're working on. So what's a better statement? If you build it, document it, market it, and maintain it, and I'm pretty sure probably 10 other things, they will come. And they'll stay, right? So this is kind of the principle that I adopted when thinking about this mezzanine initiative, this initiative that I want people to consume and contribute to. We want to make sure that we give you the tools and the means to move forward on this. And we bring in people like Michael Welling, who is our lead maintainer, to manage this, right? So someone who knows a lot about the topic. So as I've been talking about Michael Welling, here are the people who are involved in the initial setup of this repository. Lead maintainer, I am managing the community, whatever that means to people. And then we have other maintainers for Altium, Eagle templates, and then Michael Welling, who is specializing in KiCad. Sahaj Saru, who is also a reviewer. So, starting off, you land on the 96Boards Mezzanine Community Initiative, and you want to start getting to work. You want to start learning about what's happening. You want to start contributing. Well, we've set it up to make the ramp-up time or the learning curve as low as possible. We've provided templates that have already been proven in KiCad, Altium, and Eagle. And we have experienced people that are standing behind their templates that are driving this forward and reviewing all of the commits, pull requests that are being made. So big thank you to that. And after just, I believe, a couple days ago, I was talking with Gordon here from Gumsticks, and we would like to welcome Gumsticks and the Geppetto by Gumsticks hardware development into this fold. So hopefully within the next couple weeks, we will be bringing in Gumsticks and Geppetto links for other types of rapid development around this. And I want to just give a quick second. I don't know, Gordon, do you want to give a minute talk about Gumsticks?
I think you're on a roll, but you know the critical thing that we're trying to do is our key goal here is to make it possible for somebody to go from a concept to a product in 3 weeks using our Geppetto design tool, which does support the 96Boards IE, the Internet edition, the Consumer edition, and the Electronics edition, and we will make all of the what we're calling Geppetto source information available in this repository here.
Great, so now not only do you have templates for KiCad, Altium, and Eagle to build your mezzanines out, say you want something that's rapidly deployable, rapidly available to you right away. Well, now you have the option to go to Gumsticks, go to Geppetto, work with that. And again, Gordon actually gave a nice presentation yesterday. For those of you watching, make sure you go check the Geppetto Gumsticks presentation by Gordon. All right. Have I gone over my half a time yet, Lonnie? I'm still good, 10 minutes. Great. Now, I mentioned, right, that this repository, while it's still new, it already has output, okay? So people have already consumed our templates, and they have contributed. We have a Proto mezzanine that came up here. These are all initial phase mezzanines that are testing the capabilities of what we can do, right? So we want to make sure that we have our high-speed and low-speed connectors measured properly, right? So we're not going to go build some super intricate mezzanine and then plop it on and see that they're not aligned properly, right? So some of these ones are just initial mezzanines. We're testing our ability to tap into the high-speed header. We're testing our ability to expand and do through pins, our abilities to bring out IOs. This one was by Barry Byford over in the UK. This is an OLED screen. He put on little Pong games, all sorts of cool stuff coming right off the high-speed header. So again, beginning phases. from our Altium and EagleCat side, this is a 3G industrial IoT mezzanine that they are also going to expand on. Right now it's modulated, but they will be bringing that to further level as well. And there's an entire list of more mezzanines that we will be working on. So what's in the pipeline? Open pipeline, we have GPS on it. More I/O testing mezzanines, and in fact, for anyone who is developing 96 boards, we have a very special one, but it's more probably in the long term for testing compliance. We want a single mezzanine and a single script that you can plug onto your next 96 boards, run it, and then you know that that compliance test is satisfied by a series of green or red marks. RPI header, this is kind of in debate, but we'll see where that one goes. But again, I don't have control over this, right? This is community driven. So maybe one of the companies in here wants to develop a mezzanine. You're starting to see that people want this. And that should drive you to make something or contribute or get in touch with us that are running the repositories. So how do you get involved? You just go talk with us on the repository, right? So we have all of the features enabled within the GitHub. You go open an issue, we have a contributions, I want to call it contributions policy, but like a contributions guidelines, how can you get involved? Everything's on that repository that you saw earlier. I would highly recommend, people go in there and give us your comments. If this is something that interests you, we'd love to open the conversation. And as an added bonus, we do congregate every Monday. So we congregate every Monday at, I think it's 8 a.m.?
10 at my time.
So, okay, yeah, so 8 a.m. Pacific PDT. Yeah, so right now at 8 a.m., so it'll probably change to 7 a.m. later. But we can always decide on that. And we have a strong following right now. So we have anywhere between 5 to 10 people showing up every Monday to give their input and to steer this initiative forward. And everyone is welcome to participate in this, and everyone is welcome to help steer this in the direction that they feel would benefit them the most. And we want to make sure that that goes together. Now, before I move on to Monty, I do want to give Michael a chance to kind of talk. He is our lead maintainer. Michael, did you have anything you wanted to just add to this before we move on to the technical side of things?
I think you did all right.
Yeah? Good? Okay, all right, great. So then that's it on my end. Please go find us on the Mezzanine Repository. You can go to the GitHub or 96Boards and then find the Mezzanine Community Repository. We're there 24/7. And there's an IRC channel, sorry, one last thing. The IRC channel, open hours, IRC, so hashtag open hours. And that's where we kind of also talk about this on a weekly basis, all the days, yeah. Monty, here he is.
Thank you, Robert. All right, so this is my first session so far, so I'm a bit nervous. Please apologize that. So I'm going to talk about how do we handle the future mezzanines. So since we are expanding our 96 boards mezzanine ecosystem by various initiatives like the Mezzanine Community, and we have the Proto, and a lot of initiatives going so far. So we will be having a pile of sensors mezzanines or kind of mezzanines will be coming up in the future. But we do have some issues in handling them. So I'm kind of believing that this talk is going to address them, and it's more like an conversation. It's not like a talk. It's like gathering the suggestions from the audience. So if you do have some suggestions, please let me know. We can discuss. So these are all some of the types of mezzanines we have so far. I have categorized this based on the applications. So most of them are like the level shifting mezzanines. Our baseboard is, we have a specification set for 1.8 volt, and most of the sensors are available at 3.3 or 5 volts, so we can't directly interface that. So we have a lot of level shifting mezzanines, and one of them is sensors mezzanine, which is very good for all applications. And we do have analog mezzanines. It has the MCP module, which is the ADC, so we can interface some, so we can actually gather some analog inputs into digital. And we do have audio mezzanines, which has the 3.5 mm audio jack and a couple of mics in that. So we do have camera mezzanines, a star vision MIPI adapter, and D3 camera mezzanine. So D3 camera mezzanine is somewhat cool. I hope you find some demos of that in the Aero store. And there is one Aero mezzanine also, which is the Aero Code 2. And we hope to build some drone using that. So that's in the pipeline. So these are some of the future mezzanines which is going to come. So like Robert mentioned, we do have a I2S Mezzanine issue opened up in the Mezzanine Repository. So when I talk about issue, it's like the initiative is going to come. So when you want to, in the Mezzanine Community, Mezzanine Repository, if you want a particular type of Mezzanine to be there, just open a Github issue and talk about that. So we do have an I2S Mezzanine, which should be having the external codec to manipulate the I2S out from the whatever the baseboard you are using. And we have the ZPS Mezzanine and Robot Mezzanine, which is very cool. And I hope Michael Willing has made on pretty cool Robot Mezzanine, which has the motor controller, people generator, and IMU unit also. We do have the connectivity Mezzanine, security Mezzanine, and RPA header. I don't know whether RPA header is going to come or not, but yes. So these are some of the pain points we need to address before starting with this. And one of them is detecting the onboard sensors. So like I said, the previous mezzanines were only level shifting mezzanines, so we don't have any onboard sensors in them. But when we expand our ecosystem, we will be having a lot of mezzanines having their own sensors in them for the particular applications. So how do we detect them? Most of them were not hot pluggable, so they'll be controlled using the I2C or SPI. So there's no way of auto detecting that. And automatically loading the corresponding drivers, yeah, it's necessary. So we don't need to write a whole bunch of new kernel module for dealing with the driver. We want to use the existing driver in the Linux kernel. So how can we do that? And yeah, notifying the kernel about the addition of the mezzanine. So we do want to enable a few GPIOs. We want to resolve the buzzers based on the type of mezzanine attached to our system. So how are we going to deal with this? Alright, so one of the solutions I prefer is the diversity overlay. So diversity overlay has been proposed by Pantelis. I don't know how to pronounce his last name, so I'll call it as Pantelis. Okay, so it's been in the mainline Linux kernel since 3.19. And so that diversity overlay can be enabled by using the kconfig option of overlay. So it actually selects off dynamic and off resolver, which is needed. And Free Electrons, one of the interesting company. So they actually added the support for diversity overlays in the libftt, so which is headed by David Gibson, I guess. And so what they did is, so they actually wanted to enable the diversity overlay handling in all across. Right now, so the diversity overlay methodology has been implemented in the Linux kernel. So before Free Electrons involvement, so what they wanted to do is they want that methodology to be present in the libftt, which is part of the diversity compiler, so that whatever the project other than Linux kernel using that, they can benefit from that. So they added the support. Maxim report added the support, I guess. In order to compile the diversity overlay, we do need a @ flag. So we need to pass that to the diversity compiler while compiling as an overlay. So it will produce a DTPO file, which is the overlay binary. And so one of the few interesting things is that, so you need to compile both the diversity as well as the diversity overlay with the @ option, so that we can actually apply those overlays onto the base device tree, which is very required. So for that, we need to introduce symbols in the base device tree, also symbols, fixups, and local fixup nodes in the overlays for actually handling that. So the entire specification for the device tree has been maintained by diversity org, headed by Grant Lively and Rob Herring. Okay, so right now we have the diversity overlay binary and the base diversity compile for handling the diversity overlay. So how do we merge those two things together? So these are some of the possible methods put together. So first one is merging all overlays into the base device tree. Yeah, it doesn't make any sense because you don't want to populate all the nodes for the future things which is going to come, which may or may not come. So like you don't want, if you're having hundreds of mezzanines, you don't want to populate the base device tree with hundreds of nodes for handling those mezzanines. It doesn't make any sense. And second thing is using the config.fs interface. So this is actually an interesting thing. So it allows you to load the diversity overlay dynamically into the kernel from the user space through the config.fs file system. But it is not recommended, yeah, because it poses some security concerns. I hope you can read those things in the mailing list conversations. So it too was introduced by Pantelis, and it's not accepted mainland. And third thing, one of the preferred method is to use the bootloader to apply overlays. So this is actually a preferred method because you are not allowing the kernel to deal with all these kind of shits. So you are actually handling the applying diversity overlay part in top of the Linux kernel. So this is one of the preferred method. So that and the fourth thing is using a clone of Cape Manager. So Cape Manager is a feature introduced by Pantelis for handling this diversity overlay methods, like dynamically inserting the diversity overlay into Linux kernel. So it is also not accepted mainlines because I don't know. So so this actually has the syslabus interface for loading overlays. So so the Cape Manager has been implemented as a MISC driver in Linux kernel. So I hope you can find those patches in BeagleBoard as well as the Raspberry Pi downstream kernel. It's already there. Okay, so right now I need to take two things. One is the using bootloader to apply overlays, and another one is using the Cape Manager sort of thing. So I would consider this as a preferred method for handling the overlays. So we can actually use bootloaders to apply the overlay binaries into the base device tree before it handles off the diversity pointer to the Linux kernel. And yeah, we need to specify the overlays via environmental variables. So this is actually a quite interesting thing. There are a few methods for doing that. So either we can actually create, we can actually load all the binary diversity overlays, overlay binaries in the SD card, and you can specify the name of those diversity overlays in the environmental variable or in the SD card U-boot environmental variable itself, unv.txt, so that the bootloader can pick those things up and then collect it together and merge it into the base device tree. So yeah, it requires no change in the kernel. Yeah, and it's one of the much recommended way for handling some of these diversities. And so when we talk about this, we do have a problem because we are not using a single unified bootloader for our 96Boards ecosystem. So we have different types of bootloaders. One is the U-boot and the second one is the allocate. So U-boot is like, it's used for high-key, it's used for bubblegum and some other boards. So U-boot already got the overlay support. It is already mainlined by Free Electrons Maximum Repart. And but when we talk about allocate, it doesn't have any. So no support exists, but patching should be easy because we already have libability in allocate. So when I think LK is using probably an old revision of libability. So it should be a matter of just upgrading that libability and then introducing some APIs for just passing the overlay name to that and then merging it together. It should be fairly easy, I consider. Yeah. Alright, so this is the last result, using the Cape Manager to load overlays. So yeah, like I said, Cape Manager has been implemented by both Raspberry Pi and BeagleBoard. So we need to, if we want that same interface to be present for 96Boards, we need to introduce a new interface. I don't know how's that going to be. So so the overlays can be stored in WP ROMs on the Mezzanine itself, or it can be stored in the root file system. So this is up to the community to do that. So we are not enforcing anything, so it's up to the community to decide. So when we are designing a future Mezzanine, so we would recommend you to place a WP ROM on the Mezzanine itself for detecting that Mezzanine, so that if you are going to implement this feature in the Linux, in our kernels, I don't know, so it will help us to identify your Mezzanine and then load the corresponding drivers. So if you are going to place the root file system, your diversity overlays in the root file system, we are going to be in trouble for some of the use cases. I'll come to that. So we can use the one-wire bus for identifying the mezzanines because we can't use I2C or SPI. So one-wire bus is it's more useful because we don't have the dedicated pins for in the low-speed expansion connector for identifying the type of mezzanines. For that thing, we can use the bitbank, the W1GPIO driver. So it needs to be hacked because one-wire interface cannot be used for auto detection straight away. So we need to hack that. So I think Free Electrons already did the hack for their chip initiative. So I think it should be easy. So yeah, so once we detect the type of mezzanine attached to our system, then we need to load the overlays. So it will be problematic if the overlays are stored in root file system, because so the root file system will be accessible only during the later stage of the boot process. But what if you are using the display related mezzanines? So it could be very, very problematic for detecting that. It could be at the time of loading the overlay, we might have finished a lot of steps. So it'll be very problematic for the DRM kind of things. So it should be considered. And yeah, it should be done at the initial stage of the boot process. So I don't know, if you are storing it in root file system, I don't think it is possible. But if you are storing the WPROM, it may. So yeah, support cannot be mainlined. Yeah, since I told you that these are the Cape Manager support has been fragmented, it's across the different SPCs. So if you were focusing on our 96 boards specific kind of interface, it cannot be mainlined. It should be a generic kind of thing for it to be merged into the next kernel. So yeah, other SPCs supporting these Cape Manager thing is Beaglebone Black and Raspberry Pi. So yeah, these are all some of the conclusions I have for handling the future mezzanines. But if you have some other methods for detecting that, please let us know so that we can discuss that.
Good. Quick question maybe. That kind of assumes you have some processing power on the mezzanine, right?
Yeah.
It's not a pure sensor, it's not something with just extensions. You need at least a microcontroller on your mezzanine.
No.
So, but you need something with either you connect to EEPROM to or something to bit bang a GPIO thing. So you need something to answer, right?
No, we don't need that.
The 96 board. 96 board.
So
reads
PS board will do
EEPROM,
the processing.
Most of us.
Okay, but you need to add an EEPROM to that.
Yeah.
On the mezzanine.
Yeah.
Yeah. But so it's read by. You don't need the process run.
Okay.
Yeah.
Sure.
Are there any boards already planned to let me say, create a kind of an evaluation platform
No,
with the
I think we need to discuss with Aaron regarding that.
Okay.
We can actually implement example use case so that others can also adopt from that.
Yeah.
I can speak a little bit about, and I'll speak a little later today as well, about use of device tree. We are really pleased with the evolution of the device tree right now and its use for identifying mezzanine boards. We can store an awful lot of information on it. Our strategy is not specifically Cape Manager, but we do store device tree information in the EEPROM that is then used by the processor on the 96 boards. The single biggest challenge is having a standardized device tree approach across different 96 board kernels. So there's, it's a different kernel being used for, the Dragon board versus the Hikey versus the others, and having we've got something internally that we use, but I think for others, having a standard strategy for having the device tree read across multiple, not the kernel, but the CPU underlying the kernel is a big deal. I guess.
Thanks, Laura. So, in order to demonstrate these two things, I have implemented, I have actually patched the U-boot for actually merging the overlays in our Dragon Board 14C. So, I have a blog written for that. Please go and check it out. So, I have this, it's actually in my private Git repository. It's not in the 96Boards U-boots repo. And so I have written a detailed instruction of how to load overlays using that. So I was using the SD card to store the overlays, and then I'm using the unv.txt file to mention what are the overlays we need to use. And I do have some implemented the config.rs interface in my personal repo for the Qualcomm kernel. So if you guys want to check it out, please go check it out. Thank you. That's it.
Yeah, so I just want to remind everyone that we have our open hour session coming up at 3 o'clock. Anyone who wants to know more about 96 boards and Linaro in general, Mike Levine and I will be doing a 101 talk for engineers around 96 boards and Linaro, following a panel of very, I think, esteemed people in the community. In fact, Gordon will be on there. Like he said, he'll be talking more about this device tree work that they're doing along with Geppetto. Grant Likely will be on there. We have representatives from Red Hat. We have representatives from Qualcomm. It'll be a nice panel. So 3 o'clock, and I believe it's in Cypress A, or B. Well, anyways, you'll see a panel of
Quite
people
the
up
full
here.
room, hopefully.
Hopefully we get a bigger
Coming
room.
from outside that aren't in the connect. That
Yeah,
aren't
we'll be
here.
joined by universities and some people from the outside. But yeah, thank you very much. It was really a pleasure.